Hey, Jonathan here. This is going to be a really quick 10-minute-ish kind of summary of a live stream I just did on processing data faster with any tool. So this was a live stream I did earlier, and the whole live stream I think was about an hour 15. So this is going to be just a really, really quick condensed version of that. So let's get started. Okay, now effectively, the principles we're going to be looking at and using are computer science principles, right? So these 6 principles that I have down the side here, they're kind of what you would learn in typical computer science 101, except I'm going to be teaching this a bit differently instead, because when you're a data analyst, you're not necessarily working with things like arrays and lists. And I guess the thing that I haven't really put down here is algorithms. But you're not necessarily always kind of designing your own algorithms and stuff. As a data analyst, a lot of times you're thinking about things like tables, right? So you're used to things like Excel, possibly SQL, possibly R, or Pandas, like. You're looking at things like data frames. You're looking at tables, basically. So a big part of this is really going to be going over how to do that kind of data processing faster, the kind of data processing that you're already kind of familiar with. So let's get going. Really quick summary. So I put together this chart here. Let me move this again. And this doesn't really cover all of the attributes of all these different tools here. It doesn't really cover all the tools either, but this is kind of one way of looking at things, right? We have all these different tools where they are fast or slow and easy or hard to use. Now, when we say fast or slow, what are we talking about here? You can be talking about this is how fast it is for the computer to be able to do things, right? Because computers read things in a sort of fairly different way to humans do. Now, a lot of times, these things that, to get from kind of human language to computer language is a whole bunch of processing done. And some of that's done more automatically for you, and some of it's done less automatically for you. And that's going to kind of play into how difficult or easy it is to actually use a particular tool, because the really easy tools, they don't really involve any code at all to be able to do anything, to the far end over here where you need a lot of code, and you're talking much closer to the computer language to be able to do things. And throughout this summary, we're going to be kind of taking a look at what some of these computer languagey kind of things are. But effectively, when you're using some of these languages like C and Java, you get much finer control over these kind of things, and that's why these things go a lot faster. But again, they're much, much harder to use. Whereas these kind of programming languages in the middle, they're kind of the compromise between having no code at all and having fine control over the way that the computer works. And effectively, the other kind of dimension to this as well is really functionality as well, because typically when you move into something like a programming language, you're going to get a lot more functionality, right? So moving on, I think I've already spent quite a bit of time on that, so I'm going to have to skip through this pretty quickly. So the first thing I talk about here is reducing the amount of travel for your data, right? So here we have things like a CPU, we've got memory inside your computer, hard disks, network, and say this is the internet or cloud or something, right? So as you can see, that this up the top here is capacity. So this is the memory inside of a CPU, and you can see that that's relatively small. Every time you go up from, sort of the CPU memory to sort of RAM, to hard disk space, that these are going up by like 1,000 times each time. So they grow a lot bigger in capacity, but at they pretty much equally go down by pretty much the same amount in speed, right? So effectively, the more that you can do in the kind of lower ends of here, the faster your application is going to be, is kind of the gist of it. Now, how do you actually kind of do these kind of things in practice? Well, a few simple things for, even if you're using like Excel or R or kind of whatever, is the fact that, you're always kind of loading data off your disk, right? To be able to do things. Now, and so you can get a lot more efficiency just by only reading it off when you actually need it to be read off. And maybe shrinking stuff down, different things like that. And we're going to talk about that a little bit more in data types and memory management. Again, this is a really quick summary of a much longer talk, but there's a whole bunch of things effectively that like Excel and even R do that right back to the disk unnecessarily. I mean, some of them are built-in Excel things, some of them are just user things. So anyway, there you go, moving on. So now we're looking at data types. Now, as mentioned previously, we only have a certain amount of memory, and we want to spend as much time in the fast memory as possible and as little time in the kind of slow memory, right? So we've got these different data types. So Boolean is like a true false value. Then we've got characters. Obviously you need lots of characters to make up a piece of text. And then you have things like integers, which are effectively whole numbers, and doubles, which are numbers with decimal places, right? And there's lots of other data types as well. But anyway, this is just here to give you a very quick illustration that when we're working with data, the computer actually has to allocate memory for these kind of things, right? So just because you have a small number on a page or something like that, it doesn't mean that it's necessarily using up a small amount of memory. Think of memory as a bit like a set of drawers, right? Now, if you have a big thing that you need to stick in a drawer, you need a bigger drawer. And if you decide that, and if you don't know what you're going to stick in the drawer, you have to get a big drawer just in case that you end up with something big, right? And this makes things a lot less efficient, right? So as you can see, from the smallest data types to the kind of the biggest data types over here, you could effectively process 64 times more data with the same amount of memory, the same CPU processing, just by using a smaller data type. I mean, if that's possible, right? So it's something to think about there. Now, often in, say, something like Excel, or at least a spreadsheet part of Excel, I mean, you don't really get that much control over this at all. But if we come over to here, this is a screenshot of Power Pivot. Now, Power Pivot is a now built-in feature of Excel. And what you can see is that this actually starts to look a lot more like, say, a database or a data frame in R or something like that, where you actually have columns with column types, right? So I've got 1.2 over here, which is effectively a double. I've got ABC, which are these text-based fields. And then I've got this drop down, and you can see like all of the different data types here. Let me just move this over. So to a certain extent, you can start to get a little bit more explicit about data types, even in something like Excel, if you're using the right features. Now, I go into more detail about this because, even when you pick the data fields here, when you go back to the spreadsheet model, it still suffers from a few bits and pieces. But anyway, you can watch the full live stream to get more details on that. Okay. So now let's talk a little bit more about, well, this is kind of a continuation from the other one, so maybe we won't spend too long here. Now, this is why languages like C are quite fast and quite powerful, because you're able to manage the memory in a much more granular way. And you're also able to specify the data types in much more detail, right? So that is that. Now, from say an Excel or R kind of user perspective, what you're kind of thinking about here is maybe you're wanting to shrink down your data so that it doesn't take up so much space, right? So that's kind of one thing to think about. It is sort of different, but kind of, yeah, it's still sort of memory management. But effectively, pre-aggregate your data is going to work a lot faster. Okay, moving on. Reducing calculations. So every time a function is called, it's going to run a certain amount of calculations. Now, especially once you get into code and you start writing loops and all this kind of things, then you can end up calling functions a lot of times. And Excel in particular, the spreadsheet part of it anyway, is particularly slow at this because a few things. One, every time you fill down a formula, you make multiple copies of it, which means it needs to call that function multiple times, right? Whereas in other kind of programming languages, you're doing a single function call, maybe for the entire column. And so obviously if you have a lot of rows, then this is going to be much slower in something like a spreadsheet. And again, Excel is much more than just a spreadsheet. That's why if you're using things like Power Query, you can do these calculations much faster. The other part of this as well is that in the spreadsheet model, the upside and the downside of it is that everything recalculates. Like every time you touch anything, it calculates anytime you click into a cell. It calculates anytime that the thing is auto-saving, or which is like every 10 minutes, right? And this is why, larger spreadsheets can stall and end up being very slow. So reducing the number of calculations can massively speed things up as well. Okay. So parallel processing. Now, parallel processing basically means we have more computers, more CPUs and everything processing our data all at the same time, right? Now, the thing I wanted to point out is that the thing I talk about is, one, R by default is not multi-threaded. So it actually only uses a single CPU to process things by default. Now, the reason why it's still so much faster than, say, something like Excel is actually to do with structures, which we'll talk about next, right? But an easy way to make R run in a multi-threaded way is using the Microsoft version of R, which is actually free. And I talk about a few other potential benefits of using the Microsoft version of R in the live stream also, so you can go and check that out. Now, one of the things I want to talk about is parallel processing is the use of cloud. So back in a previous slide, I had a picture of the cloud or internet, how that's actually the connection is really slow because to send massive amounts of data over the internet to your computer to process is just really, really inefficient. So why is it that cloud is a good strategy to make things fast? Well, the reason for that is that you don't send all the data down to your computer. You just process it all in the cloud and only send down the summaries or the aggregations of that data back down to your computer. So you're taking advantage of the cloud and you're not sending data. And when you're moving to the cloud, you get these massive parallel processing. If you have to serve up data in like lots of different locations, then you can have lots of different servers in lots of different locations. And this is another big aspect of the cloud. But I have a few more examples of that, again, in the live streams. So moving on, structures. So this is the big thing that I find really interesting. And this is one of the things that actually makes a really, really big difference. So up the top here, we have three tables actually. And a lot of times we just think a table is a table is a table, but that's not kind of really the case. So up the top, we have an Excel table, and this is a cell-based model. And one of the things about the cell-based model, good or bad, good and bad, is the fact that it's very, very flexible. In other words, you can stick anything you want in any of these cells, right? So I can have these very flexible calculations. and they will calculate, recalculate on the fly, and all that sort of thing. But we're not specifying what kind of data goes in each column. We're not specifying a column name, a column type, or any of that sort of thing. And even if we did put column names across the top here, and only put a certain type of data in each column, Excel is just not strict about these things, and because of that, it ends up being a lot slower for that. Now, on the left here, we have a number of rows, and this is basically a representation of a database. And again, there's multiple different types of databases, but often when you talk about databases, you're talking about relational databases like Access, like SQL, like MySQL, SQL Server, Oracle, those kind of things. And those type of databases are also known as relational databases, are record-based or row-based databases. And what a lot of people don't realize is, because a lot of times people think, whenever I need to start merging data, then doing a join in something like SQL Server is, like 1,000 times faster than doing a VLOOKUP in Excel. But actually joins are relatively slow because you have to join all the records on the table. And a lot of times when we're working with data, a lot of times you're wanting to aggregate the data up by columns. So, this is this mechanism here is actually better optimized for one, transactions, and two, for storage, right? So that's what this kind of structure is good for. Now, for analysis, what you really want is something that is structured like this over here. So this is a column store. And when the data is organized by columns instead of rows like this or cells like this, then it can become a lot more efficient for aggregating data, which is a lot of times what we want to do. We want to sum up a column, right? We want to get the average of a column, all these kind of things. Now, when you're using things like R or Python or some sort of column store database, then this is kind of the default kind of format. And this is why these tools work so much faster for analysis. Now, even if you're using Excel, there are some ways that you can get column store databases inside of Excel. Now, it's not the spreadsheet model, but you can have things like Power Pivot. And I talk about that, the pros and cons of that in the live stream as well. Okay. So finally, I talk about the other types of data structures, which are not table-based. And I'm not going to really go into these too much now because, again, I cover this a lot more in the live stream. But these make different kind of questions much more efficient to answer. And if you want to go into the details of that, you can see the other video. But it's really useful to know that there are other data structures besides tables, which we're used to working with all the time. And this can definitely open up our toolkit and ability to do more things. So anyways, that is a super quick summary of the live stream that we just did. And if you want to find out more about what I'm doing, you can visit me at www.datastrategywithjonathan.com. If you found this video helpful, please leave a thumbs up. For more videos, subscribe to my channel, and do check out the live stream if you can. All right, thanks for watching. I'll see you next time.